So in this video, we're going to talk about how to use regressions to make decisions. So let's look at this example. It says that a company has tracked its annual profit since 2009. Each year, the company hired 50 new full-time workers to increase the number of units it manufactures. Use the table of values to find a quadratic function to model the data, then determine whether the company should hire 50 new workers in 2017 too. Okay, so it's talking about the time since 2009, okay? So instead of entering the actual years into my calculator, what I'm going to do is I'm going to write these as the number of years since 2009. So for example, 2009 is 0 years since 2009. 2010 is 1 year after. 2011 is 2 years. 2012 is 3 years. 2013 is 4 years. 2015 is 5. 2015 is 6, and then 2016 is 7. Okay, so I'm going to use that as my values for L1, and then I'm going to use the profit in millions as my value of L2. So I'm going to go to Stat, hit Enter on Edit. If you already have values here, remember you go up and then click Clear and then Enter. So I'm going to go ahead and enter these numbers into L1. So I have 0, 1, 2, 3, 4, 5, 6, 7. And then I'm going to enter the profits. So we have 1, 2, 2.8, 3.5, 4, 4.5, 4.7, and 4.76. Okay, so now that I have all these values, remember I go to Stat, arrow to Calculate, and choose option 5 for my quadratic regression. So I keep hitting Enter, and then hit Enter again, and now it gives me my A, B, and C values. So I'm going to round to the nearest thousandth as it tells me to do in the problem. So I have y equals negative 0.074 x squared, and then b is 1.057, so that's with x. And then I have plus, my c is going to be 0.999. Okay, so 0.999. Okay, so that is my equation. And so it wants me to determine whether the company should continue with this in 2017. Okay, so 2017 is going to be 8 years after this start in 2009, right? So 8 years will be 2017. So I'm going to go to this equation. I'm going to plug in 8 for x. So I have y equals negative 0.074 times 8 squared plus 1.057 times 8 plus 0.999. Okay, so I'm going to type this all in my calculator. So I have negative 0.074 times 8 squared, and then plus 1.057 times 8, and then plus 0.999. And then if I hit enter, that tells me that y equals 4.719. Okay, so if I look at this trend, notice that it is going down, right? So I was here at 4.76, which is kind of a high point. At 4.719, I'm going back down. So it is not a good idea because remember that quadratics, what they do is they go up to a certain point. And then they kind of start to fall back down, right? So that's what happens when you have this quadratic where a is less than 0. So it's going to hit that max value, which I'm guessing is probably around 4.76, and then it's going to start going down. So it is not a good idea to continue with this trend. Okay, so in this problem, it says that 2 kids run a summer lemonade stand and they are going to earn $100 each to give to the Children's Hospital. Their total profit for the first 7 days is given in the table below. Find a linear model to fit the data. Okay, so we're going to go ahead and go to Stat Edit, and we're going to enter these values into our L1 and L2. So we clear, enter, and then in L2 we clear, enter. Okay, so in L1 we have our days, so we have 1, 2, 3, 4, 5, 6, 7. Profit is 4, 6.2, 7.9, 10.1, 12.5, 13.8, and 15.7. Okay, so now what we're going to do is we're going to go to Stat, Calculate, and we're going to choose Linear Regression, which is option 4. And we are going to get it to give us the equation. So we want to round to the nearest thousandth. So we have 1.057 Actually, let me write it as y equals. So we have y equals 1.961 x plus 2.186. Okay, so that is my linear model. Notice the R value is close to 1, so this is a pretty good linear model. So we want to figure out how many days before they both earn enough to give to the children's hospital. Well, they want to earn $100 each, right? So $100 each for two kids, that's going to be $200. Okay, so we want to know when this amount is going to be bigger than $200. So we have to say 1.961x plus 2.186. We want that to be greater than or equal to $200. So now we just need to solve this inequality. So I'm going to start off by subtracting 2.186 from both sides. And when I do that, I get 1.961x is greater than or equal to, and let's see, I have 200 minus 2.186. So when I do that, I get 197.814. Now to solve for x, I just need to divide both sides by 1.961. And when I do that, I get x is greater than or equal to 100.87. Okay, so that means that they're going to have to work for more than 100 days, right? So about 101 days, they will have to run this lemonade stand in order for both of them to earn $100 each to give to the children's hospital. Okay, so now in this problem it says a biologist has been studying a population of wild rabbits in a park. The biologist noticed that the population is increasing at an exponential rate each month. A team of vets has agreed to participate in a catch, spay, neuter, and release program when the population goes above 750 rabbits. Find an exponential function to model the population of rabbits in the field. Use the model to predict when they should start catching the rabbits to spay or neuter them. Okay, so let's go to stat edit and let's enter these values into our tables. So I'm going to start off by clearing both of these first. So in L1 we have 1, 2, 3, 4, 5. In L2 I'm entering 30, 50, 70, 100, and 152. Okay, so if we go to stat calculate, remember we're going to choose option 0 for our exponential regression. And now we get this equation. We can plug in these values to right. We have y equals a, which is 21.255, right? Because it says round to the nearest thousandth, times b, which is 1.483, and that is to the x. Okay, so now what it wants us to do is predict when they should start catching the rabbits. So they want to, start this program when the population goes above 750, okay? So since the number of rabbits is y, we want to figure out when 21.255 times 1.483 to the x is greater than 750. Okay, so now we need to solve this exponential equation. Well, I'm going to start off by getting that exponential term by itself. So to do that, I'm going to divide both sides by that 21.255. Okay, so when I do that, all I'm left with on the left is that 1.483 to the x. Okay, so I have 1.483 to the x, and I'm trying to figure out when that's greater than or equal to, and now I need to do 750 divided by 21.255. Okay, so when I hit enter, that gives me 35.286. And now I need to solve this exponential equation, okay? So remember when we do this, our strategy is to take the log of both sides. You can take the log or the ln, whichever one you prefer. And so we have log of 35.286. To solve this, I'm going to need to bring the x down in front. So I have x log of 1.483 is greater than or equal to log of 35.286. So now I need to divide both sides by the log of 1.483 in order to solve for x. Okay, so when I do that, I end up with x is greater than or equal to, okay, so now let's do this. We have log of 35.286, and then I hit enter, and then I'm going to divide by the log of 1.483. And when I hit enter, I want x to be greater than or equal to 9.04. Okay, so I'm trying to figure out how many days. So I want to, sorry, not days, months. So I want to kind of tell them to start this program after 9 months. Okay, so you want to use that to inform your decision. So we have sorry, I don't know why it did that, 9 months. Okay, so that is the X value that we are going to suggest to these scientists and vets. Okay, so you can use linear, quadratic, and exponential models to represent data and make informed decisions.